For today's video, I'm going to be going over 4 exponent laws, so let's begin. Starting off with adding exponents. When we add exponents, the bases must be the same and two values must multiply. So, for example, if we had the value 2 to the power of x multiplied by 2 to the power of y, we can add the exponents because the bases, which is 2, is the same, and these two values are being multiplied with each other. So what we'll get is 2 to the x plus y. For subtracting exponents, it's when two similar bases are being divided by each other. So that's when we can subtract the exponents. So when we have 2 to the power of x over 2 to the power of y, we can go ahead and write that as 2 to the x minus y, right? Because the bases are the same and they're being divided. Now when multiplying exponents, this is when we have an exponent within a bracket and an exponent applying to that outside of the bracket. So let's say we had the value x squared cubed, right? For this, we would go ahead and we would multiply these two values. We'd multiply the two exponents, and we'll write this as x to the power of 6, right? The base stays the same. Now, when dividing exponents, this is when roots are involved. So let's say we had the values, the square root of 2 to the power of x, right? One way we can write this as is 2 to the x over 2. So what did I do? The numerator of the fraction is what is inside the root, and what's outside of the root goes on the denominator. So right here is the numerator, right? And right here is the denominator, right? The denominator goes all the way out here. The numerator goes inside the root. Now let's go over some examples. So let's say we had 2 squared multiplied by 2 cubed. Now one way we can do is we can, apply the exponents. So 2 squared would be 4 and 2 cubed would be 8, and we can multiply those two values. But another way of writing it is by adding exponents because the bases are the same. So since the bases are 2 and the exponents is 2 and 3, we can add 2 and 3 together to get 2 to the power of 5. Now for this one, we notice that the bases are not the same. So we can't add it like that unless we change bases. So I see that the 4 can equal 2 squared, right? Multiplied by 2 cubed, right? So what I did was I changed the bases so the bases are the same. Now we can use the multiplying exponent rules and we can multiply these two values here. So we get 2 to the 4 multiplied by 2 to the 3. This means that 4 squared is equal to 2 to the power of 4, right? Now that we change the bases, we can now add the exponents. We can add 4 and 3 together and get 2 to the 7. Now for subtracting exponents, we have 3 to the power of 3y divided by 3y. Now for this, we can go ahead, since the bases are the same, we can subtract it. So that would equal 3y minus y, and we can simplify that to 3 to the power of 2y. Now we have another situation here where the bases are not the same. So what we can do is we can go ahead and change the bases. So we have 10 to the power of 5, right, over 100 squared. So what I'm going to do is I'm going to change the 100 squared into the base of 10, right? So 100 squared is equal to 10 squared, right? And we'll apply that right here. And we'll do what we did before, and we'll multiply the fractions together because there's an exponent inside and outside of the bracket. And that will give us 10 to the power of 5 over 10 to the power of 4, right? And this would be our solution. But we can take this an extra step and subtract these, and we'll get 10 to the 1, which is just 10, right? Now, moving on to the next example, we have 2 to the power of 4 in brackets squared. So we can just go ahead and multiply these two together, and we'll get 2 to the 8. Now we have 3x squared to the 6th power. And here we're going to apply the 6th power to each term, so the 3 and the x squared. So for the x squared, we can multiply the two exponents, and we'll get 3 to the power of 6 and x to the power of 12. Now 3 to the power of 6 is 729. So we'll simplify this to 729 x to the power of 12. For this next example, we have 4y to the root of 2x. So the first step we're going to do is we're going to change the base of 4, and we can simplify that into 2 to the power of 2. So we'll have 2x right here, 2 to the power of 2 to the y. Now, using the multiplying exponent rules, we'll get 2x, right? We can multiply the 2 and y, so we'll get 2 to the power of 2y, right? Now we can use the dividing exponents, and remember that the inside of the root is the numerator and the outside is the denominator. So we're going to get 2 to the 2y over 2x. But remember, this can be simplified into 2 to the power of y over x, and that would be our answer. Now for the final example, we have x to the power of 5 to the cube root. So as we said before, the inside of the root goes to the numerator of the exponent fraction, and the outside goes to the denominator. So we can rewrite this as x to the 5 over 3, and that is our answer.